live. Okay.
Hi,
Yes.
myself.
All right.
My future self.
The other day, when we did quadratic word problems, I gave you a problem like the armadillo. Jumps up into the air, right? And he goes straight up in the air from the ground, and he lands back down again. And the question was, how long did it take for him to land on the ground, right? How long was he in the air? And what did we have to figure? What did we have to solve for?
The time.
The time, okay? But in those problems, we had something like this, right? And here's the armadillo, and he jumps straight up and straight down. But since this is time, and time started to move, it created this thing, right? And where am I? And this is my height, right? This was my height. So what was I looking for?
The time when the other
I was either looking for this time or this
part.
time. Which time?
The
This
second
one, right? And what do you call that?
Unless you jump.
What am I asking you to solve? If I give you an equation that is modeled, that shows that parabola,
Oh, the
The
parabola
time
goes with
second.
the zeros.
I'm asking you to find the zeros, right? Is that clear? I mean, that's what we were doing on all of those. We were finding the zeros, finding the roots, finding the solution for x, right? Finding where it crosses the x-axis, right? Finding the x-intercepts. All those things are the same thing. All right. And on the homework tonight, just so you know, there are a couple more like that. Only they're not armadillos. They're like divers or they're things. But you know how to identify when they're asking for the time. They're basically asking for the zeros.
Are you ever
right?
gonna make us
Does that make
graph any?
sense? What?
Are you ever gonna make us like graph any like that?
Eventually, yeah, but you're not going to have to graph these tonight. But if I'm asking you to tell me the time is almost always put on the x-axis, right? And so the height makes sense that height would be on the y-axis because you often want to see the height. You know what I mean? Height is going up and down. Time is sort of a horizontal thing. It's like it's moving while you're going up and down, right? So. So if they're asking you to find the time, usually they're asking you to find the zeros, right? Now, let's read this problem now. This is a different type of problem, and it's not using the vertical. Now, in the past problems, we were using the vertical motion model, right? Remember that? H equals negative 16 t squared minus vt, plus vt plus s, right? Right? And but this is now not a gravity problem, right? So it's going to be, you don't have to have the minus 16t and everything. Okay, here we go. It says, the height above the water level of a curved arch support for a bridge can be modeled by f of x is equal to that something there, where x is the distance in feet from the arch support, from where the arch support enters the water. And then it says, can a sailboat that is 24 feet tall pass under the bridge? So the first thing really would be to draw a picture, right? I mean, that would be the easiest thing, to draw a picture so that we are sure we understand it. So, okay. So here's a bridge. All right? And here's the water, right? Right? And then here's my arch support. Right? Does that make sense?
That part.
Does that make sense so far?
Yeah.
And so, all right, so I just want to make it look like an arch support. All right, so it's an arch support. So the question is, can my sailboat, right, the little sailboat, you know, that has a mast coming up here, and this mast has a little flag on it, right? And that is at, let me get my sailboat, right? And that is 24 feet tall. This sailboat is 24 feet tall. And they're asking me, can that sailboat pass under that bridge, under that arch support? What would I need to know to answer that question?
The height of the tallest point in the
Does everybody agree with that?
Yeah.
I would need to know the height of the tallest part of this arch support, right?
Yes.
Of the bottom of the arch support. And so that is a parabola, right? So what are you being asked to find?
The vertex.
The vertex, right? That's almost always, you're either being asked to find the zeros or find the vertex, right? Piece of cake. So that's all we have to do. We have to find the vertex. And hopefully, which one, when I have a point, when I find a vertex, I have an x and I have a comma y. Which one will tell me the height? You guys, please stop, okay? Which one will tell me the height of the sailboats, the height of the parabola?
No, why?
Which one, when I figure out my vertex of this thing, which one of these is going to tell me the height of the arch support?
But why?
The y, right, exactly. My x is
why?
going to tell me to go this direction, right? The y is going to go in this direction. So whatever
That's
goes
why.
in that y is what I need to know to answer this question. Does that make sense?
Why?
Does that make sense to you, Elizabeth? It does? That all I need to find my vertex, and my y will tell me how high this parabola can get, the highest point. So how do I find my vertex? Micah, what would you do?
To find vertex, you that equation.
That lovely equation. I can see you
Yes,
have
it's
fond.
such a
You have a
nice
great
equation.
fondness for that equation.
When you do negative,
Yes.
negative,
So okay, what do I do?
you can do I forget the name of it, but you can do negative b over 2a.
Okay, but
The
you're
axis of
leaving.
symmetry?
Yeah, but you're leaving
Yeah.
something out of that
Or
formula.
you can turn it like
Axis of symmetry.
Yes, it's called the axis of symmetry formula.
x equals negative b over 2a, and then you have to plug it in where it says x, and then you get the
It's
y.
part of the
So
equation.
yes, so this is the formula. X is equal to negative b over 2a. And that will give me the x of my vertex, right? So I know that my vertex is going to be something x comma y, right? This will tell me my x. So now it's a piece of cake. All I have to do is find my a and my b. So my a is this. Isn't that lovely? I knew Liam would like this one. That's why I gave it to him. Gave it to you guys. And I knew this is my B, right? So I would normally do this in my head because I'm awesome. But today for you, I'm going to use a calculator.
Thank you,
okay?
Gary.
All right. So okay. Actually, but I am going to write it out.
So it'll be like negative 0.75
So
over
it's gonna be- well,
2 times negative.
Yeah,
0.005.
negative 0.75 over 2 times negative 0.005, right? All right. Whew. Okay, so we have, first of all, that's going to be a negative as well. Let me just go ahead. Well, I'll just divide. What I'm going to do is I'm going to put 0.75 negative. Well, actually, I don't even have to do that. I've noticed that this is going to be negative,
So is that?
and that's going to be negative.
So it's going to be a
So
positive.
they're gonna be positive, right? Just you see what I'm doing?
Does it mean
Immediately I
it's
know it's gonna be
0.010?
positive. So I'm gonna just
0.0.
I'm gonna forget about the negatives now because I can tell it's gonna be positive. Does that make sense?
Gary,
Liam?
isn't it going to be 0.01?
What? Liam, what?
What?
Can you put that away?
Yeah.
This is where you're supposed to be focusing on, not that. Are you writing all this down while you're doing that? I don't know what's going on.
Gary, is it going to be 0.01?
So let me just show you what I'm going to do. I'm going to take my calculator. I'm going to put 0.75 divided by 2 divided by negative not even negative, 0.005. Do you see what I mean? Because this is 0.75 divided by 2 times this, right? But I could also, instead of having to multiply this out, I could just say 0.75 divided by 2 divided by this. Does that make sense? But I'm going to keep them all positive now. So I have 0.75, where is it? Okay, divided by 2, divided by 0.005 equals 75. All right, it equals 75. So that equals 75. So that's my x. My x is 75.
What?
Wait, negative 75 or positive?
How?
Wait.
75. 0.75 is divided by that
All right,
is 75.
hang on. We'll just hang on. So we got. I'm gonna just go ahead and multiply this out. 0.75 over. Let's see. That's gonna be negative 0.010. Right? Would you
Yes.
agree with me?
We don't have to put the 0 on the end though.
So now the negatives cross out. So now it's 0.75 divided by 0.01, right? So 0.75 divided by 0.01 equals 75.
What?
Weird.
Isn't that right? Did you get
Like
that?
how many
What?
times can 0.01 go in?
Right.
Oh, I get it.
Yeah, exactly.
Yep, that's
exactly.
why.
That is a very tiny number going into a much larger number.
And it
Even though
goes
that's
into
a
that
tiny
number
too.
75 times.
Right? But that's why you use a calculator.
Yes.
You just, you know what I mean? So it gets 75. So my x is equal to 75. So immediately I put that over here for my vertex. I know that my x of my vertex is 75.
What?
Now,
That's crazy.
can I erase this? Can I erase this part?
Yep.
Can I erase this part, William? So that I can keep moving?
Is this kind of stuff going to be on the homework?
Yeah. Totally. All right. So now all you have to do is use a calculator. It's not hard. It's like really easy. All right. So now we have to figure out my y. How would I find my y?
So we're make a negative and FC.
Make a what?
Make a negative and FC.
Okay, but I don't want to use that method. I want to use.
Doesn't that sound
Then you
something?
plug it in
Yeah.
where it says X.
So okay, I'm going to plug it in. Right. This is my x. So I want to know what my y is. My f of x is the same as my y. F of x is called function notation. Okay. When they say f, that's pronounced f of x. Okay. Are you writing all this stuff? Oh, you just finished. You just got back. Okay. Right. F of x. Right.
Could we just write y instead?
No, I want you to get used to this.
Okay. But
all
it's
this,
the same as
all
y.
this is this y.
Okay.
That's all it really is. Right.
So
But
then
it's
why
just
is it
saying
like that?
this is a function. When it says f of x, it's saying this is a function, right? And a function, we're going to go into more detail about what functions are. I just want you to start getting used to it because you're going to see a lot of it in Algebra 2. I mean, almost everything is going to be f of x instead of y, just so you know. There'll be a lot of stuff, yeah.
Could we just plug this into the quadratic formula and solve it?
What does the quadratic formula give you?
Oh, finds the zeros.
It finds the zeros, and we're trying to find the vertex, right? So we use our
Yes.
negative b over 2a. X equals negative b over 2a.
But Gary,
So
what
now,
if we converted it to vertex form?
what?
What if we converted that equation to vertex form?
You could. It just looks like it would be a hard one to convert to me. Do you know what I mean? I think it would be easier, way easier to do this. So now let's just do it. Let's find our y now. So I'll go ahead and, well, let's see. So now we're saying f of, instead of x, I'm going to put 75 in here. That's one of the beauties of f of x, because it tells me, oh, I'm replacing every x with 75. So my function, when x is equal to 75, will equal, and this is what I'm going to do. I'm going to have negative 0.005 times 75, thank you, squared, plus, thank you, Sakara, plus 0.75 times 75. Ah, I'm running out of space.
And now we just solve it.
Okay, and then plus 0.9. So I'm going to first do this. PEMDAS says I do what first when I have exponents?
At X.
Right, so I'm going to do 75 times 75 equals, that is negative 0.005 times 5625 plus, I'll go ahead and do that one, 0.75 times 75 equals 57 plus 0.9. All right, let's figure out what this is. That is 0.005 times 5625 equals, it's going to be negative 29 plus 57 plus 0.9, assuming I did everything right. So 57 plus 0.09 minus 29 equals 28. So f of x, f of 75 is equal to 28. That's the same as saying y is equal to 28. When you have f of x, it's the same as y. Does that make sense?
Wait.
So I'll give you a second to write this down.
Like
Negative
f of x
29?
is the same as y.
F of x is the same as y.
Why?
It's function notation. I'm trying to get you used to it because you're gonna see a lot of it in algebra 2. And we're gonna explain more in detail what it is, right?
Isn't
I'm just getting used to it.
isn't
But
0.005?
when you see f of x, immediately think y. It's just y.
So this is
It does not
basically-
mean,
this is
just so you know,
basically
f of x does not mean f times x.
Yeah, no.
It does not mean that. Just
Gary.
This is basically just a regular. We're just finding the vertex.
so, guys, if you don't have your
Yeah.
notebooks out, you might as well get them out, right? Right?
Gary,
Yes.
how did you get negative 29? Because I did negative 0.005 times 5625, and I got negative 28.125.
Multiply. I mean, not multiply. Round to did.
But wouldn't you?
I don't know. I got that.
Yeah, I got so
So, but that's pretty close. So what you got? What? Negative 28.
negative 28.125.
Are you sure? I don't
Yeah.
know.
And
I
do you
don't know.
have to round?
I got an even number when I did it.
Oh, I did it wrong.
Oh,
So-
see, I didn't get even numbers when I did it.
So, anyways, I got y is equal to 28. So now I know my vertex. We figured out my vertex was 75,
0.005.
comma, 28.
So that means it's 28 feet tall. Which is
Exactly,
a
it's
sailboat
28
then,
feet.
not sure.
So now the answer to the question: can a sailboat?
Gary, are you sure?
Can a? No, I'm using this. I have no idea.
Someone else tried on their calculator. Someone's calculator screwed up. 0.005.
What? Are we talking about this right here? 0.005 times 5625. 5625 equals. I got 29 even.
What?
I'll do it
Give
again.
me your calculator.
Ow!
You guys, I'm in a lecture. I don't want to do this on a lecture, right?
I know,
Okay.
but
Excuse
Alright.
Gary's miss
Point
Five
use of his
005.
calculator.
Wait.
well,
sorry.
it might be us.
0.005
Oh, quadratic
times
problems?
5625.
What? No, no.
This gives you 28.125. You're right.
Yes.
So that one's wrong. Weird. Alright. So guys, I got to change this. So it's 28.
Shouldn't have
Shouldn't I have rounded it down though?
My calculator.
0.125. I'll just do that.
Gary, shouldn't I have rounded it down though?
Oh.
If it was rounding?
What?
Shouldn't I have rounded it down if it was rounding?
I miss Sophia.
Since it's going to be negative, right?
Oh, it's rounding it.
It's.
Yes.
I'm going to round. I'm going to keep it. I kind of want to be sure. Like if it came out, if I rounded this and it came out to 24 feet, then I wouldn't. It would be a little awkward, right? I wouldn't know for sure. I want to be exact. So I got.
But the calculator error shouldn't have rounded because of it was being rounded, right?
Yeah.
Yeah. I don't know why that. would be.
28.125 is
I don't know why.
rounded to 29.
Hang on, I'm gonna attempt this.
I'm not. You guys, please stop. Can you guys stop? Okay. I don't want to spend my lecture on whether that calculator is working or not. Okay. That is not what this lecture is about. Okay. I don't know which calculator is right. That one said it was 29. This one says it's 28.125. I'm going to go with the 28.125 since Clayton is so persistent. Okay. All right. So we're going to go with that one. So now we're going to use that. So I'm going to say f of 75, which is the same as y, just so you know. F of 75 is, I'm going to start with 57 plus 0.09 minus 28.125. Shoot, I just hit the 8. Okay.
Yeah, Gary.
So I got, okay. So I get it.
Gary, I just did it on two. If we've done it on three calculators, two of them say that that's right.
4.
Okay, good.
No, 1
4.
more.
All right, good.
That's right.
So the answer is that. So that is my y when x is 75. Does that make sense? So I'm going to just come over here and put that 28.125 here. That is my vertex right there. And so all I have to do now is look at the question. It says, can a sailboat that is 24 feet tall pass under this bridge.
Yes.
And this bridge is this height. It's 28 feet and a little bit more, right?
Yes.
So yes, a 24-foot sailboat definitely can pass under
But
that.
what if there was a man on the crow's nest?
Then that would just be too bad for him now, wouldn't it?
It would be too bad for him. So I just want to, since we got a bunch of people that just came in, I just want to clarify a couple things. In the previous word problems that we've had with quadratics, they were called vertical motion word problems, right?
Yep.
And we used that h equals negative 16t squared plus bt plus s, right? And it was about something falling, right? So it was gravity, right? So when it's about gravity, you're going to see equations similar to that. And there are going to be a couple like that on the homework tonight. Just like you did like the other day, right? Pretty straightforward. But then this is not about gravity. This is just saying an arch support of a bridge can be modeled by this equation, which is a quadratic equation. It means it's going to be a parabola, right? And so, and they're just asking, can a sailboat that's 24 feet tall go under that? So before, we had to find the zeros, like how long would it take him to land on the ground? Now, we're just being asked to find the vertex, the highest point of that parabola, because that's what you need to know. Can the sailboat go under that highest point, right? Right? Hopefully the captain of the sailboat knows to go in the middle of the parabola, right? And doesn't choose to start over
Well,
here.
it's a good 4
right?
feet taller than the sailboat.
But
so
most
if he's a little
captains
bit
know
off, he should be
Right?
Wait,
okay.
so what's y?
I'll just tell you this one thing. My dad as a kid, we grew up in New York State, right? And we sailed on the St. Lawrence River. And there's this huge bridge, that's sort of like the Golden Gate Bridge. That's what it kind of looks like, only it's miniature compared to that. But it's, my dad's dream as a kid was to own his own sailboat and to sail that boat under this bridge, right? And so, here I'm 14 or something like that, and we got our own sailboat, and we're up at the Thousand Islands, and there's the bridge way up there, and we're sailing along, and
Did you hit the
sailing
bridge?
along, and as we're getting closer, we're thinking, Dad, are we gonna make it? Are we gonna make it? And we're looking, oh my God, I don't know. Slow up, Dad, slow up. We let out the sail. We could have. By the time we got under it, we realized we could have had like 3 of our sailboats under that bridge. It was like, but I don't know, somehow distance is sort of deceptive when you're looking up, But it was really a spectacular
So you didn't
moment.
break your
I
sailboat?
still remember it, right? It was that special. Okay, that's it for the lecture. So.